Okay, so our next topic is the resistance. This is another popular topic of this chapter. Okay, so first of all, this resistance, already I have told you about this in class 9. Okay, though it was not in syllabus, but I have told you. Okay, so we have to know about the origin of the resistance. So what is the origin of the resistance? I have told you there are some atoms in the conductor, and when the temperature, let's say our room temperature 27 degrees centigrade, that is 300 Kelvin. Okay, so at that temperature all the atoms vibrate like this. Let's say this is an atom and this will be vibrate like this, because the temperature is giving some energy to it, and absorbing that energy, the molecules or the atoms will vibrate. Now when an electron try to pass through the conductor, what it will face? It will face that vibration. Okay, and in that way the electron will be repelled by this molecule. So it try to passing through here. এখানে একটা molecule ছিল, it can easily pass through it, but as it is vibrating, it will just resist this electron. Okay, so this is the actual origin of this of the resistance. We can think in another way. Let's say this is a molecule. Okay, this is the nucleus, and around the nucleus there are some electrons. The electrons are negative. Okay, and when another free electron will pass by the electron, the negative charge also repel this negative electron. Okay, in that way the electron also the motion of the electron will also be resisted. Okay, now think about this. When you increase the temperature, that's mean when you increase the temperature, what will happen? When you increase the temperature, the amplitude of the vibration will increase, so the number of collision will increase. So when you increase the temperature, then the resistance will increase. Then in that way we can say that resistance is proportional to the temperature. Okay, resistance is proportional to the temperature. Okay, so on which other factor the resistance depends? The resistance is also proportional to the length of the conductor. What I'm saying, the resistance is also proportional to the length of the conductor. Means if you increase the length, the number of collision will increase, because more the path, more the collision, then more the resistance. So resistance will increase with the length. Okay, resistance will decrease with the area of cross section. That's mean this is the area of the cross section. Okay, if the area of cross section increase, তার মানে দেখ তারটা যদি মোটা হয়ে যায়, then the resistance will decrease. This is inversely proportional. Okay, so combining these two, we can get R is proportional to L by A. R is proportional to L by A. You may ask, sir, why you are not combining this? Okay, because why I am not combining this, I shall tell you, just wait. Now R is proportional to L by A. Okay, and we have to bring a constant R equal to, this constant is known as rho into L by A. Okay, so what is this rho? This is known as rho, R-H-O, rho. Okay, so rho, basically rho is the resistivity, and this is nothing but a constant. Okay, and the definition of resistivity I have told you in class 9. You just open that copy and try to remember. Okay, so basically this is the formula, R equal to rho into L by A. Okay, so you have to just remember this formula because this is very much important. Okay, so what is the unit of resistance? I have already told you the unit of resistance is ohm. The unit of resistance is ohm. Okay, at what is the unit of rho? Just try to find out what is the unit of resistance, rho or resistivity. That is ohm meter, or you can say ohm centimeter, or like this, ohm meter or ohm centimeter, ohm meter or ohm centimeter. Okay, now what is conductance? This is conductance, conductance. Conductance is the reciprocal of the resistance. So if I denote it by Y, this is the reciprocal of the resistance, 1 by R. This is conductance. And just think about the conductance. Its function is just opposite to the resistance. Okay, that's mean how smoothly current can flow through a conductor, that is conductance. Okay, so what will be its unit? What will be its units? Very easy. So units will be 1 by ohm or ohm inverse. Okay, or you know this is the symbol mho. Okay, this is known as mho. So this is the conductance. Okay, and all these things are from class 9s. Okay, now next topic is Ohm's law. Ohm's law. Oh, another thing, another question may come from here. That is the what is the external factor on which the resistance depends? Okay, on which the resistance of a conductor depends, like that. Okay, so what is Ohm's law? Basically, Ohm's law is, let's say, oh, another thing, the resistance, the circuit symbol of the resistance is like this. The circuit symbol of resistance is like this. Okay, and you have to write a R here. So this is the circuit symbol of the resistance. Ohm's law. Let's say here is the potential difference, here is the potential V1, and there is another point, its potential is V2. Okay, and we are connecting this with a wire. Of course the wire must have some resistance. Okay, all the wire have some resistance. In fact, the wire used in your house, that also have some resistance, but that is very low resistance. Okay, now this is the resistance R. Okay, so let's say V1 is greater than V2. V1 is greater than V2 means V1 is positive and V2 is negative. Okay, so V1 is greater than V2 means current will flow along this direction. We are not talking about the flow of charge, we are talking about the current. So current will flow along this direction, we know that is opposite to the flow of charge. আর এটাকে নেগেটিভ বলেছি মানে পাশে বেশি ইলেকট্রন আছে, তাহলে ইলেকট্রন বেশির থেকে কমের দিকে আসবে, মানে কারেন্ট উল্টো দিকে ফ্লো হবে, এটাই তো ন্যাচারাল। ওকে, সো একটুখানি ভেবে দেখ, when you are increasing the potential difference, what I am saying, whenever you are increasing the potential difference, that's in potential difference V1 minus V2, this is the potential difference V1 minus V2, we are taking it as V. So whenever you are increasing the potential difference, then the current will increase. দেখ যত বেশি পোটেনশিয়াল ডিফারেন্স হবে তত বেশি বেশি কারেন্ট ফ্লো হবে। ব্যাটারির ভোল্টেজ বাড়লে কারেন্ট বেড়ে যায় না? সো লাইক দিস। তাহলে এখানে আমাদের একটা কনস্ট্যান্ট আনতে হয়, দ্যাট কনস্ট্যান্ট ইজ আর। Okay, so this R is the resistance of the conductor, but there is a condition. What is the condition? The temperature remain unchanged. The temperature remain unchanged. Okay, the temperature remain unchanged, and for this reason we do not use the term of temperature here, because when you are calculating the resistance, that's mean there was no change in temperature. Okay, so this is the only one condition of Ohm's law, that the temperature will not change, and when the temperature remain unchanged, then only this law is valid. Okay, so someone may ask you a question that what is the limitations of Ohm's law? So this is the limitations of Ohm's law. When the temperature changes, Ohm's law will not be valid. Okay, so when the temperature changes, the Ohm's law will not valid? Because let's say I am changing the temperature, increasing the temperature, suddenly the copper melts. ধর কপারে তার দিয়ে এক্সপেরিমেন্ট করছিস, এত টেম্পারেচার বাড়িয়ে দিলি কপার গলে গেল, তখন তো আর এই এক্সপেরিমেন্টটাই ভ্যালিড হবে না, না? ওকে, অ্যান্ড জাস্ট ওয়ান থিং, we have taken this resistance as constant, na? We have taken this resistance as constant, but when you change the temperature, the resistance will not be constant. Okay, so that is why. Now this is the important question, that is the what are the conditions of Ohm's law, or what is the limitation of Ohm's law? This is the question. Okay, so what is the limitation of Ohm's law? Okay, the answer is in book, you just try to find it. Okay.